Hi, this is Wendy Lightheart, and today we're going to be learning about rational expressions. Now, when we say rational expressions, that's just a fancy way of describing fractions that have variables in them. So the first topic we're going to talk about is excluding values from rational expressions. And there's a very important concept we need to review first before we can learn how to exclude values from rational expressions. So recall, what happens when we take a number and divide it by 0? So in other words, if a represents some real number other than the number 0, then what is the value of a divided by 0? Well, hopefully you remember that when we have 0 in the denominator of a fraction, that expression becomes undefined. Consider the rational expression 2 divided by x minus 3. What happens when x is equal to 3? Well, if we replace the x with 3 and perform that subtraction, then we get 0 in the denominator. And if we have 0 in the denominator, that means that expression is undefined. So the expression will be undefined since the denominator will be equal to 0. Consider the rational expression x minus 1 divided by x plus 5. Now when we say we want to exclude values from rational expressions, that means that we're looking for values of x that would make that expression undefined. And when we replace x with negative 5 in this expression, notice that we end up with 0 in the denominator. So the answer to this question is negative 5, since this is the value of x that will make the denominator equal to 0. Note that it doesn't matter what values of x make the numerator 0. Since 0 divided by a non-zero number is equal to 0, it's not undefined. So when we are excluding values from rational expressions, we're only looking for values of x that will make the denominator equal to 0. So you can completely ignore the numerator when doing these problems. Consider the rational expression 5 divided by the product of x minus 1 and 2x plus 3. For what values of x will this expression be undefined? Well, the values of x that will make a rational expression undefined are the values of x that make the denominator equal to 0. So to find these values, we must solve the equation that we get when we set the denominator equal to 0. Now this equation is of the form that we've been learning to solve just recently. Remember that if you have a factored expression on one side of the equal sign and 0 on the other side of the equal sign, we can solve that equation by setting each factor equal to 0 and then solving those new equations. So the solution to the first equation is x equals 1, and the solution to the second equation is x equals negative 3 halves. Thus, the values of x that will make this expression undefined are the numbers 1 and negative 3 halves. And that's because those are the two values of x that would make the denominator equal to 0. Consider the rational expression x plus 6 divided by 7x minus 9. For what values of x will this expression be undefined? Well, we want to know what values of x will make the denominator equal to 0, so we set the denominator equal to 0 and we solve that equation. Now this equation is a linear equation, so you can use your beginning algebra skills to solve this equation to get a solution of x equals 9 divided by 7, or 9/7. Thus the value of x that will make this expression undefined is 9/7. Consider these two rational expressions. They look very similar. We want to know what values of x will make these expressions undefined. Let's first look at the one on the left. Remember that whatever is going to make that expression undefined is the values of x that will make that denominator equal to 0. So we set that denominator equal to 0 and we solve. Now this is a quadratic equation, so we solve this by factoring, and this is a difference of squares, so hopefully you were able to factor that pretty quickly in your head to get x plus 3 times x minus 3. And the solutions to that equation would be positive 3 and negative 3. So those are the values of x that will make that expression undefined. Now let's look at the expression on the right. Whatever values of x that will make this expression undefined are the values of x that will make that denominator equal to 0. Now think about what number you would have to add to 9 to get 0. Well, you'd have to add negative 9 to positive 9 in order to get 0. So are there any values of x that would make x squared be equal to negative 9? Well, the answer to that is no. There's no way you can square any real number and get any negative number. So there's no way that x squared can ever equal negative 9, which means x squared plus 9 cannot equal 0 for any values of x. So we say that this expression is defined for all real numbers. And that's because there are no real numbers for which it is undefined. Now we're going to be looking at how to simplify rational expressions. So we need the fundamental principle of rational expressions in order to simplify rational expressions. So if p, q, and r are polynomials, including constants, and q and r are not 0, because of course that would make the denominator equal to 0, then this rational expression on the left, pr divided by qr, would simplify to p divided by q. And that's because these r's are common factors on the top and the bottom, and so they can cancel each other. Note that there must be multiplication between p and r and q and r, and multiplication must separate r from everything else on the top and separate it from everything else on the bottom for this principle to apply. So for example, if the denominator said q plus r instead of q times r, we would not be able to cancel the r's. They must be common factors of the top and bottom. So first we're going to look at how we can reduce regular fractions without any variables. And we're going to use a process that's going to help us to simplify rational expressions. So this may not be the way that you reduce your fractions, but this is the way we're going to learn how to simplify rational expressions. So if we take this fraction 24/30 and we wanted to reduce it, one way to do that is to first factor the top and bottom completely. So when you're factoring plain old numbers completely, that means that you're factoring down to its prime factors. So 24 factors down to 2 times 2 times 2 times 3, and 30 factors down to 2 times 3 times 5. Then we can cancel common factors that we see on both the top and bottom. So notice that we have a 2 on top that could cancel a 2 on the bottom. And we also have a 3 on the top that can cancel a 3 on the bottom. And those are all the common factors we have that can cancel. So then we multiply what's left. 2 times 2 on the top will give us 4, and all we have left on the bottom is a 5. So this fraction is now reduced completely down to 4/5. We're going to use the same process to reduce some rational expressions. So like this one, for example, 5x minus 10 divided by 15, we're going to follow the same steps. So we're going to factor the top and bottom completely. So in the numerator, all we can do is factor out a common factor of 5. And if we factor 15 down into its prime factors, we get 5 times 3. And notice that now we can see a common factor of 5 on both the top and the bottom. Notice that the 5 is separated by multiplication between it and everything else on the top and the same thing for the bottom, and that's why those 5's can cancel. And now all we have left is x minus 2 on the top and a 3 on the bottom. So this rational expression has been simplified. Let's look at one more example that'll be a little bit more work. Here's a rational expression, and we want to simplify it. So remember that the first step for simplifying rational expressions is to factor the top and bottom completely. So if we look at the top first, what's the first step of factoring? Right, factor out a GCF. So notice that we do have a GCF in the top. We factor that out. So we factor out a common factor of 3, and we're left with the trinomial x squared minus 4x plus 3. Then we look at the denominator, and there is no greatest common factor. So then we would go ahead and factor that into 2 binomials. You might want to pause at this point and try to practice your factoring skills and factor the denominator. Notice that there is a leading coefficient that's not 1, so you need to use your factoring by grouping skills. And you should come up with the factors 2x plus 5 and x minus 1. Now notice that this is not factored completely yet because we still have a trinomial in the numerator that may factor further. And it does, so go ahead and pause and factor that. And you should have come up with the factors x minus 1 and x minus 3. Now the top and bottom have been factored completely, which means now we're ready to cancel common factors that we see in the top and the bottom. Notice we have common factors of x minus 1 that we can cancel, but that's all that we can cancel. So then we simplify what's left. We have 3 times x minus 3 on the top left over, and just a single factor of 2x plus 5 in the denominator left over. And so this is our answer. And it's okay if you just leave it in factored form. You don't necessarily have to distribute that 3 for this answer to be correct, but it's okay to distribute the 3 also. So this is our reduced version of the original fraction we started with. And that's it for today. Have fun simplifying rational expressions.